Alrighty, polynomial operations. Here we go. You guys have done this before. You just might not have done problems quite this long before. So we're going to simplify each expression completely. We're going to incorporate properties of exponents into the distributive property, FOIL, whatever you want to call multiplying a binomial by a binomial. And then we're going to write everything in standard form. So we're going to put them in order by degree or by exponent. Okay. So step one, if you see parentheses, get rid of them. So I'm going to start off by distributing here. 3x times x is going to give me 3x squared because x to the first times x to the first, add the exponents. Minus, and then 3x times negative 5 is going to be minus 15x. And then if I switch gears, I'm going to distribute negative 4x squared next. So negative 4x squared times 1 is negative 4x squared. And then negative 4x squared times negative 2x, add, and that's going to become 8x cubed. All right, and now to finish this off, this last one is a binomial times a binomial. You guys probably know this by FOIL, maybe an acronym that you know. First times first gives me 2x cubed. And then x squared times 1 is x squared. And then I'm also going to do the negative 3 gets distributed. Okay, I tend to call it the rainbow method because I draw little rainbow arches, but I've heard it called FOIL. I've heard it called lots of different things. Double distribute. You can also organize it with a box if you want. All right, so now I've got this all organized and I've gotten rid of all my parentheses. Now I want to search for like terms, but since we have to write it in standard form, well, let's focus on the biggest terms to begin with, all right? So I've got my highest exponent that I see are these two right here. I've got an 8x cubed and a 2x cubed. If I've got 8 of them plus 2 more, I've got 10x cubes. Now, when you combine like terms, the variable portion will not change. You only change exponents when you're multiplying or doing a power to a power, okay? But when you're adding, combining like terms, coefficients change, but exponents do not. All right, let's see. What do we have next? We've also got, let's see, x squareds. 3x squared minus 4x squared plus 1x squared. Let's see, 3x squared minus 4x squared is negative 1x squared. Negative 1x squared plus x squared is 0x squared. So guess what? They just perfectly cross each other out. I don't even need to write an x squared in my answer. All right, moving on. I've got 15x, negative 15x, negative 6x. So that's going to give me negative 21x's. And then that standalone constant is left all by its lonesome, minus 3. So this is my final answer in standard form. 10x cubed minus 21x minus 3. All right, so that was a combination of multiplying and adding and subtracting all in one problem. All right, let's take a look at another one. Problem number 6. Always deal with exponents first. Now you're going to be tempted to say, hey, can I just distribute that exponent? The answer is no. This is not properties of exponents because it is not a monomial. As soon as you see addition or subtraction inside of a set of parentheses, you can no longer apply the properties of exponents. This is really 4c cubed times 2c minus 7d. Squaring something means multiply it by itself. And now you can see that this is really just a multiplication problem and not a properties of exponents problem. My recommendation is to deal with the parentheses first. So I'm going to leave, the 4c cubed there for right now. And I'm going to multiply this out to start. All right. 2c times 2c is going to be 4c squared. 2c times negative 7d is negative 14cd. And then I'm also going to do the negative 7d gets distributed. Negative 7d times 2c is another negative 14c. Negative 7d times negative 7d is a positive 49. D times d is d squared. All right, I do have like terms in there. You can distribute first or you can combine like terms first, whatever you prefer. I'm going to go ahead and write 4c cubed times, and I'm going to merge these two bad boys together. And you know what I just realized? I forgot to write the d. You're probably looking at me like I'm crazy. There's a D there. Sorry about that. All right. So I've got 4c squared. 14cd and 14cd is 28cd, so I've got minus 28cd. And then plus 49d squared. Now I'm going to distribute and have a final answer. You don't have to worry so much about standard form when you have more than one variable involved. I should have mentioned that before. All right, distributing 4c cubed times 4c squared is 16c to the fifth, power up to a power. You add exponents. Minus, let's see, 4c cubed times negative 28cd. 4 times 28 is 112. That'll be c to the fourth times d. And then for the last one, let's see, 4 times 49 comes out to 196. And then I'm going to have c cubed and d squared. So that's my final answer over there. I have a habit of writing everything in alphabetical order, but you don't have to do that. As long as you have the right letters with the right exponents, you're good to go. All right, problem number 7, a bigger multiplying problem. All right, let's take a look at multiplying 4 times everything. Goes first. So I'm going to get 4a squared minus 12a plus 20. And then I'm going to multiply the negative a cubed to everything. So that's going to give me minus a to the fifth from adding exponents, plus 3a to the fourth, and minus 5a cubed. And now I have to distribute this subtraction sign over here. Distribute the subtraction sign to everything. It's very easy to forget to distribute a subtraction sign. So now I'm going to have minus 2a cubed minus 3a squared plus 4a to the fifth and minus 4a. All right, and now it's the quest for like terms again. And you want to focus on the highest exponent first. So I see a negative a to the fifth and a 4a to the fifth. Those combine to give me 3a to the fifth. If you want to cross things off as you use them, you're welcome to do that. Maybe I'll do that with a highlighter so I can see what I've done. So those are gone now. Now I want to focus on the a to the fourths. A to the fourth, and that's my only one. So I'm going to have plus 3a to the fourth. And now I can get rid of that. Then I've got my a cubes. Let's see, what other kind of line could I do here? We'll do 2 lines. A cubed, a cubed. Those two are going to combine to minus 7a cubed. Get rid of those. All right, and if you're choosing to cross things off as you do them, you need to make sure that your work is still legible, okay? So you're not crossing off to the point that you can't read it anymore. Let's see my a squared. So I'm going to have a positive a squared. And then the plain old a is negative 12a. And minus 4a is negative 16a. And then the plus 20. All right, so this is my final answer here. All right, so lots to do with polynomial operations.